Okay, we're back. We're reconnected. Okay, I don't know what happened there. But we're back, hopefully. Okay. Stream preview, we got going. Okay, cool. Let me know if everything's cool on your end, chat. And, yeah. I guess there was some kind of blip there or something. All right. Well, it's not too far into the stream, so hopefully it'll be fine. Yeah. So, I'll just give the little blurb so I don't have to like stitch the videos back together again and all that stuff. I'm Agent Ultra. Here we are, programming recreationally for the funsies, and we're gonna do some functional programming tonight. I've been working on learning how to build a mud server in Haskell, and we're working on a particular component of that server, a entity component system. So I've just been talking about mutable vectors and vectors in Haskell, the difference between them. And so last week I learned a little bit about unboxed vectors in Haskell. And unboxed vectors are used where you want to pack data in a contiguous array in memory, usually for the purposes of performance. So that in our system here, when we're writing our server, we can tick through, we're going to update all of the entities that have position components. And we're going to update all the position components. And then we'll update all the other components. And we have the contiguous, all of the data for that in contiguous regions of memory so that they can be fed to the CPU in nice, tightly compact cache lines and everything can be nice and quick. Right? That's the purpose of ECS systems. Some people just like the API of ECS systems. I'm not super sure we're actually going to need the performance of an ECS system for a mud server. But I'm just curious. And that's what mostly this project's just all about, right? It's just learning, figuring things out. You know, if it's not worth, the juice isn't worth the squeeze, then, you know, nothing ventured, nothing gained. That's okay in a learning project, right? That's why we program for fun, and we program just to figure things out and put things together and learn stuff. So anyways, enough rambling about that. The limitations here that we have with unboxed vectors, though, is that these product types, we can sort of pack them in to unboxed vectors, but there's some limitations on them. And namely, tuples. We have to do them in tuples, it seems like. So we can't write like a position record and then like write the ISO unbox position instance for that and then have it packed in. I don't understand exactly why, but we messed around with that quite a lot last week trying to get that to work, and it just wasn't having it. So ints seem to tuples of ints seem to work, but just not plain old records. And so I was like, that's could be fine. Maybe you lose the accessor functions that are generated for you from the record definition. You could write them back in yourself by hand. That might be slightly inconvenient. What if you want to write your components as just like plain old records? Right? Or you have, and the other thing too is that the tuples aren't like unlimited, right? They're not unlimited. I think this class and like a lot of the types in mvector and vector are defined up to like tuples of 6 elements, I want to say. So pretty limited there as well. So I'm thinking the approach we could try out is to do something similar, right, as the unboxed vector library. So the unboxed vector library, when it takes a tuple, is actually allowed to structure it in such a way in memory that there's a contiguous array for each element of the tuple. Right? So your X and your Y in our position case here. But 6 isn't going to be enough, so maybe we could do that ourselves explicitly, and then we could just maybe like wrap it up in a little template Haskell to kind of generate the code for you, so you don't have to like write out a bunch of stuff like this and just make nice happy accessors. So you can access your component data out of this kind of like composite structure. This is almost like a structive arrays sort of approach you would take in C for doing this sort of stuff, right? And if you had more elements, it'd be a vector of those as well. Nice thing about this approach too is like you could have different size types. You can have like words, ints, I don't know, cars, some bytes, that sort of thing, and get all your data in there. In our case, in the actual like mud server we're writing, it's going to be a little bit. We already kind of have types, and they got to map to all primitives, but we can do all that. All right, so position component. Let's kind of like try and make one. I think maybe we can do MMD with vectors. Okay, cool. So we don't have a show instance for it. I don't know if we can derive one. Will that be fine? That might be fine. Okay, so there's our elements, our x's and our y's of all of our components. Right, and so the idea would be if you want to get a particular component, you get it by basically its entity ID. All right, so let's say we have an entity ID in scope. We'll just make it a type alias because we're just... Right. And then if we want to get a particular element out of there, out of our position component, we can look it up by its entity ID. So we'd have to have some kind of function, right, that gets its entity ID and, well, looks into our vector for it. So it's going to have to return maybe. We have to get our position component as well. All right, we can even turn it back into a position. If I get rid of these, could, yeah. Don't compile it, comment it. Okay, I don't, for some reason, my fingers are doing a thing and it's not reacting the way I want. Okay, right. So we could even map it back out to like a position record now. Instead, single element. Right? Right, makes sense. I think so far. Alright, so we get an entity, and we get maybe a position when we look inside in this position component record for it. Alright, but it's nice fast O1 to look up, so should be pretty straightforward to look for it. All we got to do is get our entity ID. Okay. We get our pos x from looking into the vector. We have, I think our handy-dandy vector function will be how do I want to write this? I'll just write it out this way. The x of position component with vector operator and entity ID, I think. we do the same thing for that one. Vector dot w. And they'll be at the same entity ID always. And if that all works, then we can return here, position, pos x, pos y. Okay, there's a parse error on here. Oh, did I use... Oh, yeah, let me just make it a little easier. Unboxed. And... maybe I didn't need the backticks, but... oh, what's going on with that? Fly make. Okay, reload this code. Oh yeah, okay. Shadows existing Python, that's fine. Does it? Position X, position Y. Oh, yeah. We'll just rename that to component. Oh no, I forgot. I recently like tried to fix my Emacs and just wiped everything out. So I got like a bunch of packages I normally use that aren't installed now at the moment, which will just take 2 seconds to find and install. Nope, no, that one. There we go. Right, that should work. Okay, cool. All right, so if we try to get, we have entity ID 1 and our, oh, let's define our position component. All right. So our getter function, maybe we should call it get position component. I don't know, whatever. Anyways, you get 1 from P, and then we get nothing, right? Because there's no data in there, that sort of thing. So what if we have a way of adding a component to it? For entity ID. We get a new position component. Right, oh, we'd need a position, of course. Okay, and so once we have that, the function for inserting, I think, is just add. Or no, probably just insert. Mapping, monadic mapping. Modify. Update. Nope, partitioning. Nope, 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 nope. Not folds, products, or this or that and the other. Come on, where is it? Where is it? I thought it was like in an update or... Because we can index into it. Head last, unsave. That's all that good. That's all good. Yes, yes, yes. Extracting, no. Replicate, generate, iterate, no. Don't need to unfold. Or enumerate. Or concatenate. Well, we can snuck. That's not quite what we need. We also need to, while I'm thinking of this too, like, I'm trying to add a component at a particular index, right? But these are going to be, these vectors are going to be, well, they're growable, but I'm wondering if we should, if they can be sized. Right. So we could say like, okay, make me a, you know, I'm going to only have like 200 entities. I only support 2,000 entities, whatever it is. And then we can construct it so that it's just 2,000. And then we could have like indexing and stuff that would like check if it's bound and all that stuff. Okay, well, I guess we got our / or update. Anyway, we get a list of one element. It's not the greatest API. I'd rather just have like a element-wise update. That would be nicer. Right, so we have an initial vector of length m. Right, okay, so they are sized. All right, well, let's import that. So for each element of the position, we have to update each of those vectors in position component. I don't want to read this way. It's, sorry, for the slash. It's the vectors and then the updates is the second. So for the X of component, with slash, the position X of our position, and the Y component, position Y of our position, say. No, this completely fails. Put here and there. Let's not do it that way. Hey Buzztronic, welcome to the stream. Are you able to see everything this time? Ah, still Air 1000, eh? Dang. Well, thanks for popping by and let me know again, but I still haven't figured it out, apparently. A real pal. So we'll get the position, X of the position. I'll update that in the X component vector. And we'll also do the Y as well. Yeah, it's streaming at about 3,000 kilobits per second, 30 frames per second. I'm getting a few drop frames, but I think there was some initial network stuttering, something going on there. Then... So we couldn't match... right, the API is list of tuple. Right, we haven't used entity ID yet, so that's going to be our first element there. That makes sense. There we go. Now, maybe there's like an optimal streaming video ratio, like aspect ratio. That's what I'm looking for. There's an optimal aspect ratio for streaming on mobile or to the mobile client. Optimal aspect ratio, OBS, Twitch, mobile. Thanks, AI. It thinks it's 9:16. I mean, maybe for certain clients, but yeah, I don't know. I'll have to take another pass at it. But you're on PC as well. Well, that's interesting. Well, thank you, Buzztronic. I will try to have some fun, but now I'm sad that you can't join us for the video part. Best of luck to you, and hopefully you come back again and try one more time. Maybe I'll do some little streams throughout the week, test streams throughout the week to try and figure that out. What's going on there? Okay. So our add position function is implemented now. Right, so let's get our component P. With our empty vectors. Thanks, Buzztronic. So we add a position for the entity, hypothetical entity ID 0. We'll create a position of like 10, 10. That component P. We should get, what do we get? We get a call stack error because the index is out of bounds. Okay. So we do need to initialize with a particular size for our vectors. Unboxed vectors, so I think initialization's pretty straightforward. Empty vector is obviously not what we want. So we'd have to have empty elements or base elements for each of our primitive types to fill out an empty component thing. So we'd have to construct P more like this. Either would generate, replicate. I can use replicate in this particular example. Int is our size. Let's say 10 elements with 0. I don't think I've vector imported. Maybe it's already done it for me. That would be great. There we go. So then at position 0, P, we can do that. Okay, cool. So there we go. Man, would I like those type level vectors, the size and the type, so that I know, instead of checking at runtime, at compile time, I could know that this entity, I can't add entity 11. That would be super sweet, wouldn't it? Yeah, but then we get into some type level programming. Yeah. All right, so if we added at 9. Right, now this is constructing a completely new position component every time, right? Which is not what we want when we're using mutable vectors, right? we want to be able to mutate them in place. That's another reason why you might want to use them. Right, not just for reading things really, really quickly, but also for doing efficient updates to a lot of things all at once in one pass. Right, without having to use any fancy functional data structures and the extra overhead of them. Okay, so cool that we can add one though. Maybe we could do a proper mutation function though. I think we're going to need ST for that, if I'm not mistaken. And do we have an ST, like, kind of API for unboxed vectors? We got lists, other vector types, mutable vectors. Here we go. Oh, okay. I'm looking at the mutable API right now. I think the immutable API data to box, unboxed. Yeah, we're in unboxed. Oh, that's free. Sorry. Yield an immutable copy of the mutable vector. Okay. Yeah, these should be mutable. So, we need our, I think we can do it in the ST monad. All right, let's see if we can do that. All right, control.monad.st. That's also, we also want to make sure that these are strict. Probably the vectors themselves. Oh, not dirt. That. Okay, and then instead of add position like this, where we return a new position, we do st position component. I might still need the input one. Well, maybe it's in the vector library they have. Maybe they have an API for this already kind of set up. Unbox.mutable and vector. Okay, that's what we should be doing. We're using the immutable ones right now. Yeah. Oh, yes, this is what we want right here. Okay, M vector. Okay, let's convert this over. So this will be bad. This will be good. M vector. Oh, sorry, vector, not in vector. And you want one more argument. Your SA argument. Okay.
One night I had a dream, right? What if there were this club where no Hasbro kids went that played half dance music and half indie?
Okay, can't get driving your show on them anymore.
Well, this is what I did. Firstly, I had to get a venue. I checked out loads in Sheffield.
Like this? Can we do that?
Some not so good. I'd even call them crap. But I decided on this underground club. It weren't underground because you didn't know where it were. It were underground because you had to go down some steps into it. It felt right. Next up, I had to get somebody to give me an hand. They needed to be good. So I got this mod called Joey. I picked him because he hated mods even though he looked like one. I wanted it to be a cool club, like I'd been to in Paris and London years ago. There's stuff London.
I gotta change this radio station. What is going on here?
Can I say that? I just have.
It's the same channel I always use, but whatever. Alright. In a hoozle. Okay, so in vector we get our like moves, setups, accessing individual elements, reads, writes, add position, all that sort of goodness. Prim monad M, unbox A. So if I give my position component S, what do I get now? We'll revisit you in a second. Okay, so I'm in an ST at the moment. Do I need to be in an ST? Can I be in an ST to write? Each of the parts of the component. So let me import that qualified. Let's import the type though. Probably do the same for mvector, but I'll just leave that for now. It's just whatever. Okay, so we got st there. Now, what we want to do is mutate each of those component values with the right function in here, assuming that we're in a prim monad context with an unbox A element. Right, so I give it my m vector as the first argument, the int, where I want to write, and the value I want to write. The x of the component. The int is the entity ID, the index, and the value. And then we shall write the y. With our qualified name. Oh, what? It doesn't export right? Oh, data.vector on box.mutable. Ah. Map. Okay, we don't need to import st. No, okay, so how do I m vector, modify m vectors? What do I do? St vector s. Yeah, okay, so I do need st. Yeah, I just don't need the functions from it. Okay, that's what I was saying. Okay. There we go. Okay, now we're good there. Okay. All right, so I could control.monad.st here. We can run st, run our function. Okay, on our thing. Okay. So let's get set up with a position component. In fact, can we just reuse this one? Right, we need m vector. Okay, we don't have that initialization. Replicate. Yes, that should be fine. Oh, it's got to be in our monad. Okay. Makes sense. Makes sense. Okay, so our x is vector then. Uh, 10, 0. Okay, so that is... Okay, defaulted to double because it didn't have the type information to know that we meant int. Okay, there. And y's vector replicate 10. Also int as well, and then we can get p to equal our position component. If I could ever type on stream, that would be great. X's and Y's. Okay. Now I can run our add position function in st. Right? It's not like run st. I just want to run it IO. Yeah, no, we'll just run st. Position. All right, our entity, let's say 0. Our position will be 5, 5. And on P. Okay. We're getting type mismatch on the S parameter there. Expected position component S, actual real world. Mm-hmm. All right, so that's the type of P right now is position real world. Add position here just says S. And it seems like we can't get rid of this S here because then we wouldn't have any definition for it in the fields. I don't know what the way to do that is. Okay, st2io. Since we ran it in IO, st2io. Okay, that's like our REPL is basically running in st2io. Okay, so we'll instead do that. Okay, so now we should have mutated it at 0. Alright, so that's good. Now we need to bring back our get position component so that we can like actually see our mutation take effect. Alright, so we get our position component S here, entity ID, and this is going to be another STS, maybe position though. Alright, so pause X here, no longer a maybe. It's now running, this bind now means a bind in ST, so this doesn't quite make as much sense as it once did. Okay, but we need our read function. Oh, excuse me. Okay. Never mind. Let's see. This is still. I go back to the. I think it was just read, if I wasn't mistaken. Yeah, and oh, we have read maybe too. Cool, cool. Okay, so how do we do this one? Because that's going to be inside of our ST. It's going to return our maybe. Vector read X component at index entity ID. The Y component at entity ID. Oh, there we are. Well, it seems I have found a little friend. An ant has made its way to my basement. Okay, sir. Or ma'am. Where are you? Off you go. Any hoozle. Just don't bring any friends. I like ants. Ants are some of my favorite creatures. That was a... Common garden and Capanotus Niger, I think. Okay. Yeah, so we have our maybe, position X, position Y. Oh, sorry, I meant to use read maybe. Or was it maybe read? Read maybe. There we go. Yeah, maybe int is what we want. And then we want to bind those together and get a maybe position. So I'm going to reach. There is look at the time signature find. So we had our maybe int. It takes a function a to maybe b. Returns maybe b. Okay, we get just 3. Alright, if we had nothing on the left side here, then we just get nothing. And so could we use that to construct our maybe position as a return type? Remaining pure here is pure in ST. Alright, so we can't just have pure position like we had before. Well, let's put maybe pause X. Right, then we could have our X position. Right, and then we have a function here. Right, we can go, okay, well, what do we return? What does this function return? It returns another monad again. Or maybe. Right. So in here, maybe we return out again. And what are we going to return that whole? Oh, maybe position. We have pause Y and pause X in scope, so. Alright, now we can do pause X, pause Y. Sorry, it was here. Okay, we could clean that up, but that's the gist of it. Okay, so now we should be able to mutate our position thing and all that sort of stuff. So let's get our X's. Let's get our Y's. Let's create a component. Let's add, or we can even just test this out, position component. At 0 on P. Okay, we got just 0, 0. And then if we mutate that, right, add position 0, 10 to P. Then we look at P, or sorry, we look at the position component, the position 0, P, and we should get 10, 10. Oh, there you go. Right. And so that's actually mutating that vector in place. So there's, right now in my REPL session, there's somewhere in this process, there's some memory sitting there in a continuous region in a vector, right, that the garbage collector is taking care of and can move around, but it is a continuous region. It'll be moved all around together. And I'm mutating it in place with Haskell, right? So it's not always the case in Haskell in functional programming either that you have to do, like, you can never have mutation. It's just controlled, right? So like ST, I think we read in the documentation somewhere that it's escapable, so it's not perfect, but it's supposed to like kind of like control and where you do mutation, right? And being a little bit more, it takes a little more ceremony to do. So yeah, you want to do as much stuff as you can with pure code and immutable data structures, for sure. It's the happy path, the easy path, which is just a different experience when you're working in something else where like mutation's the default, right? You kind of have to go out of your way to do immutability and be really disciplined about it, right? Same thing, just inverse, flip it around, right? I personally think this is like, this is the way I think I wish a lot more programming languages were doing. Immutable first, and controlled mutation is there, as it prevents, well, it prevents a lot of bugs, but it also makes things like us doing the MUD server and like having multi-threaded applications a lot easier to build. Right. Okay. So we get rid of that old code and this stuff. And this is what our prototype looks like now. Okay, so this is the one individual component record we want to store. Right, this is more like a storage kind of thing. But we want to split out those components into vectors. So we store each of the data, and then we index into those vectors for the entity by the entity ID that we want to access the component for. And then we have like kind of these baked little functions here for adding components, getting components. We probably need to have one for, maybe we'll need one for modifying components. Because the next part of an ECS system is going to be systems, the system part, right? And the system part is, what is it going to want to do? You're going to want to be able to query all of the available components for what you need. Or you're going to be able to write a system that says like, okay, I'm working on position components. And so I need the position component as my input, right? You could write a system that says, okay, well, I need the position component, and I also need the velocity component, right? If you're doing some kind of physics type system. And in that case, you need those two inputs. So you need to be able to find those components when we run our ECS. So, we'll need to think about that at some point. Forget it for now, maybe. Okay, so we can add positions, get components. No, we can add a component, get a special component. Yeah, we do need to modify, though. I'm gonna rename this, though, to, like, get position. And then we want to modify the existing one. All right, so we'll take a function that will be our position to position. We can make this one pure. And then we'll add our position component thing. And then we'll run that here. Does this make sense as a type? Okay, what if entity ID is outside the scope or the index range of our position component, right? That would mean, like, you give us an entity ID of 100, we only have 10 entities in the system, like, what are you doing? And what else? Well, we haven't. The other thing is the uninitialized state. I was just noticing. We were just noticing, I guess, when we kind of set this up, right? These are vector ints, right? Just because we've got them doesn't mean it's actually used yet, right? The slot for any of these isn't used. All right, so we might need some kind of notion of initialization in our elements. Now, I don't know if M vectors can only store primitives, so I'm pretty sure they can't store maybes. So each component could have an extra metadata vector. For its initialization state. Big bool is probably defined for those. So then we'll just update add position. And then that also begs the question, what if it's false? Add position, sure. If it's true, should we? I'm not so sure. So maybe we could return a result type here. All right, in the case where it's already active, return some kind of result indicating that, or otherwise that it was successful and we added the new component. And same with modify. And then we can have a write position, which would not just try to add the position, but just overwrite whatever's there. And that one could be more like this. I don't know if I like the idea of like having like maybe entity ID. Right, the just case means it was added. And the nothing case means it was not. It's not too hard for us to say. Something like that. All right. A little bit more descriptive. Let's just clean that up a little bit there. Bring that over to the left a little more. Make it easier to read. Yeah. All right, so we'd have to read it first. Active. Entity ID, and then we can match on it. Nothing, then we're fine. I'll do the mutation. But if it's already active, then we gotta return success entity ID. And otherwise, fail. Okay. That's happy. And that's fine. Okay, and then this one could also do a similar thing.